it is a like good research direction that I'm working towards, like how to bring fairness to these models and take keep those underrepresented classes in check. If you have any ideas, you can pitch in. Maybe we can work on it.
Yeah, some of the guys joined a little later. Can you give a more brief explanation to the new ones who joined in? Like the
Okay.
Aditi, Kanishk, and Shatabarto and Gorika joined pretty late.
Okay. So basic idea behind this whole research paper is like it was presented in ICLR 2017 and was given the best paper award. So like it was the biggest breakthrough in that year. So next thing, what happened is like uh, the main thought behind the paper is like if we can preserve data leakage and not leak any sensitive data. So hold on. Okay, so what's the main approach behind it that it's taking the idea of like the relation between a teacher and a student. The teacher gets to decide what information is to be given to a student. So that's the main like methodology behind it. And how it does it is like it divides the original data set into like disjoint data set. By disjoint I mean it's like each sub data set is like different from each other, and train n classifiers on it, and then get a count of or vote of each label that is there, and use that as the actual labels of the data, unknown data that is feed it to the aggregate teacher model, and then using that data set as the training data set for the student model. That way, a sense of privacy is maintained. Uh, I think, yeah, is it clear or do you need any more?
Anybody has a doubt or anything?
No doubt.
Uh,
Okay. Yeah, I think because like I
uh,
think it would have happened like this. Like they were sitting in a meeting and he would have thought I'm giving some
yeah.
information. I'm restricting
Actually,
some.
what I would like to know is like this part, is this the current state of the art technology in differential
Yeah,
privacy, or is there
that is
something better?
that is the state of the art right now.
So like I think Google is using it in the what I read about it. Like Google is using keyboards, like how Google keyboards train on the using differential privacy, right?
Yeah, it uses federated learning for that, and I think yeah, I think it's using Pate as well.
Okay.
Yeah, aggregate each other's. Yeah, what? Yeah, like it's what I'm doing is right now is working on like that thing. Like I told you, I'm working on underrepresented groups and how they can be done. So some of my experience like showed me like that Pate is able to like distinguish this gap that is there between different sections of the society. But DPSGD isn't able to do that. For example, like I did some experiments on MNIST, and what I learned was like Pate. What I did was like imbalance the eighth label, because it's like eighth number is like similar to all, most similar to all the other digits. So I was trying to like determine what impact it will have. Then I did the same for DPSDT, and I realized that Pate was able to like guess that class label very well than DPSDT, because in the end I got like I tested it on 1,000 samples, and Pate was able to only guess like 50 or 40% of the eighth class samples, and DPSDT was able to guess like 80. So there was like a lower price there. So yeah, it's an interesting field if you want to work in.
Okay, that's great. So what are like the apart from the imbalanced data set problems, what are other problems that are currently being faced? And
Oh, okay. Other problems are like uh, in the field of political science, there are a lot of things that lead to data leakage. Like I don't know if you have heard, like there was a recent article about Taiwan and the problems going on there. So like the article was written using like deep learning differential private model, and it was able to like succumb all the uh, sensitive data that could be have been leaked. So like it's interesting that this technology is used in these kind of fields as well.
so
And
like how
yeah,
like it was I'm sorry, I didn't get that. Like article was written using a differential privacy model.
yeah,
Uh,
like it was fed some data related to the uh, like I think there's something going on in Taiwan. I haven't read into it, but I just read the headline that differential privacy was able to like uh, give like only the necessary information to the people, rather than giving us information about the like person in the article.
so if I'm not wrong, can I like add differential privacy as a layer of a wrapper to existing models in order to get privacy in those areas? Like for example, NLP
Uh,
models and all that stuff.
Actually, what happens is like if you want to add privacy after you have trained the model, it's very difficult, because uh, in the end you have to teach it to like differ between the data while it's while it's learning basically. So while training, I think it should be done. I haven't thought about like creating a wrapper for it, but I think it's interesting if something that like that can be done, because it will like solve all the major problems. Right now, what we are doing is like we're retraining all the models using DP, but if we can create a wrapper, we don't have to retrain them. We have to just add the wrapper class over it.
All right, that would be interesting.
It would be
Anyway,
great
anyway,
to, yeah.
yeah. So like I actually have no idea, but like it would be interesting. So, um, but do you have like any thoughts about like the general models like the GPT and stuff? Wha- Like how what's your take on like differential privacy with them? Like they access all the
Okay,
data, so
yeah.
they could be used to like unclassify this data.
Uh, yeah, basically the main use for like privacy is in this domain as only, I guess, like saying voice and text, because I don't think it would matter. It like affects images that much. But what's happening is like we can like apply it to NLP as well, but there would be a like like you can't apply Pate, I guess, because if you are using sequences, then creating disjoint data set would be like a lot. difficult task.
Yeah,
Like you'll have. So I think GPT, if yeah, GPT has given like good results, right? It was
yeah.
able to like,
GPT-2 was not that good, but GPT-3
see,
is really good. But GPT-3, like even today, there was like some Reddit bots and Twitter bots that people couldn't differ. Like, is this a human or that?
yeah. Yeah, but I think Google came up with a new technology, right? Some recent, I don't know. It was a transform only, but it was like able to perform better than GPT-3
Yeah,
with
so
less
GPT is
parameters.
like good for show off, but like it does not have a really good practical application.
Yeah, it's not
Like you can
deployable.
show off like yeah, it can generate articles, it can do programming, but it's not really good, very good at anything. So that's the issue with. Yeah, yeah,
Yeah, yeah.
yeah.
There's a field called split learning, which is able to like perform differential privacy on NLP as well. I haven't worked on in it, but like I've heard about it. Split learning is dividing the data like model into different models and then using it to create a pipeline. Hold
Okay.
on, I can share some resources if I can. Saturday? Uh,
I
Hold
think
on. Yeah, okay. I'll just drop it in the group, or you can like get it from their official like GitHub repo. If you read the paper, they have mentioned like GitHub profile. Yeah, if you can try that. In Open Mind, we are doing this. We are trying. Like we are using Swift and those libraries for that. Different languages
I
as in
think take
Python, Python and those stuff. Python and R that way. I'm not saying Swift. I'm saying Swift. Swift is a like library for in Python.
yeah, like Julia perform a bit better because like it is compiled down to C, but
Mm, yeah, like it would be
training time
faster.
would yeah, like after it has been compiled it would be faster come by I but that like inherently they are different. Like Python is an interpreter, Julia is a compiled language. Yeah,
You can give it a try. Like if you can create some library in Julia for this, because in okay, that's cool. Then you can just like search for Open Mind repo. They have PySwift they have developed, and you can just try and like that way Julia can also like implement DP as well. And wait, I can share like few papers here if you want. Uh, uh, like I'll share the names. You can like search it because I don't have the link to the official archive. This was one paper. This one I'm sending is like written by the founder of Mind. and like it was like very good, like because structured transparency is not maintained in any model. So, and I guess one more was there. Okay, just go if you want to like work in this field, then you should like go through like one paper that I mentioned in the slides. I'll share the slides as well. Yeah, I think this is. Uh, so, any questions
Like, uh,
or any discussion point?
like one question, but I think that would be related to the maths. Like, how do
Yeah.
you decide how much noise should be added to a particular
Okay.
set?
Hold on. Let me share with you something. Hmm, can I get this? Uh, you're asking how much noise we should have, right?
Yeah.
So I can share this. Are you able to see this? Like this is a like this is a
Reserve.
paper like introduced like DPSGD, and yeah, like this is the basic like mathematical definition of implementing DPSGD. It's using an epsilon value and a delta value to like change the original data set from differ sorry to
PR
differ
is probability of
yeah.
what is the M
M is like
read?
member of data set, like a randomized mechanism it's following.
Okay. So why are they taking the exponential?
uh
It
Exponential, why are they taking it? Because
and this is the hypothesis, right? Uh,
yeah,
Okay,
actually
I
what
don't
they
know.
have done is like they haven't made that much clear why they are taking exponential, but they have made it clear why they are using epsilon here. And like the original mechanism was like only till this part,
Okay,
but then the delta value or the noise factor that is added here, this therefore like brought privacy to the model. Hold on.
okay.
Yeah, this is the algorithm grid. You can,
Yeah, I think like yesterday I was going through the math, but like I had a couple of questions. I didn't
yeah,
get
math is
any
pretty
answers.
like frightening.
Yeah.
Like I can
And like
understand these things.
this is the issue with most papers. Like they are doing this, but they don't explain why they are doing that. For example, even in this, like why they're taking the exponential, why the hypothesis is like that. They don't explain that.
I think exponential is like to increase, like bring non-linearity to the model.
Oh,
Because if you make it linear, it would be like same as this data set. It won't like differ that much.
yeah.
What do you
But
think?
like why it could have then like you could take on dog also. Anyway, yeah.
Maybe like that's a good point. We can look into that. Yeah, like these are the mechanisms literally that you should lead into. There's moments accountant. Like for example, there are metrics like accuracy and everything that we do in classification. For differential privacy, there are moments accountant and strong composition mechanism and such mechanism that I use. But
Okay.
I
So
think,
yeah,
yeah.
like how much noise should we add? वो part रह गया.
How much noise should we add? That depends on that, because if you increase too much noise, the epsilon will reach zero, and then what happened will that the accuracy will decrease like tremendously, and you won't be getting any result out of it. So it should be like optimal. If you can get like epsilon 20 or epsilon 5 also gives like good accuracy. But if you go like way below that, it will like the performance will deteriorate like, very fast.
So
Basically,
like
yeah. Go on.
no, what I understood is like the query divided by epsilon
Yeah.
should be like, yeah,
Basically, what noise here is like the sensitivity divided by the epsilon value, and we are then taking a log of it.
yeah,
So
okay, so
when I told you what sensitivity is, right?
yeah,
So the main part is like if we decrease the epsilon, it will give us better privacy. That's the like it's used to calculate the budget of privacy budget. So if you are decreasing epsilon, it's increasing the budget some in some way.
and like what
Like
kind of randomized noise, like Lapel, and there are two, right?
Laplacian,
Lapel
Laplacian.
and Gaussian noise also is there.
Gaussian noise is like normal noise.
Yeah.
Hold on, let me
Oh, anybody else has any questions?
Gaussian noise is like around the mean, right? When the mean is centered around zero, you are adding it like to increase the
Yeah, yeah.
standard deviation.
So that like some parameter is equal to zero, I don't know which parameter,
Yeah.
right?
Uh, Laplacian noise uses like the gamma value that I mentioned in the slide. It's like one of gamma. So if the gamma value is like very low, the Laplacian noise would be more. So it depends on that.
Yeah.
Hold on. Yeah. True. Yeah. So any other question? That's the
Uh,
problem with like reading like top conference paper. The maths is like way too scary, and like the
yeah,
background
and
work
they
is
take like a lot of things for granted. Like the reader must know this thing, they
yeah.
must have
You
known
must
this thing.
yeah, you must have noticed like the related work section is like very large in this field.
Yeah.
The references are way too many. So yeah. And,
So one thing I like when we like on this those graphs that you showed, like validation. I was like
validity.
looking through it, and there was a graph for like validation accuracy versus epochs.
Okay. This
Uh,
one.
yeah, no, accuracy for aggregated. This is validation accuracy. Yeah, the same as that. Same
There
amount.
was another graph there.
Uh, no, it was in an article that I was reading.
Okay, you were reading an article.
No,
Actually, what's
like
happened is like,
yesterday.
yeah,
Uh, 1 second. Can I
in the
share my
original
screen?
paper,
Yeah.
there you can share your screen. Hold on,
Sure.
I can stop sharing.
Like I bookmarked it, thankfully.
Okay,
Yeah, like I want to understand this. Like, what does this represent?
what does this represent? Actually,
Like,
what's
no,
happening is like noise multiplier is like the noise that we are adding. Like if
yeah, no,
let's
like
take
if we add like 100% noise and
okay, so 100% noise, 100% noise. Okay,
no 100 noise, I think multiplier, yeah, right?
yeah, so 100 like factor 100 means like the noise is very much. That will lead to like very small value of epsilon. Do you get it? Because the model won't be after training. It won't be. able to distinguish between the original data and the noisy data that we get after it.
Yeah.
So that's
Okay.
why epsilon is decreasing. And then as for the curves that are there, that's because uh, DP like affects the performance of the model. Like when
Okay.
you're adding noise, it will definitely like decrease the accuracy at some point. If you take like a vanilla model, like training a 5-layer CNN and then training the same CNN using DP, you'll notice that the results for DP would be much less than those of the vanilla one, unless there is some like specific case of dataset that you're using.
All right. I get that.
Was I
Um.
was I clear on this the graph?
Yeah. That was clear. Yeah.
Okay.
I'll stop sharing. Yeah. So. Uh, you- I think that was it. Another thing I would thinking was the application of this that would be useful. Like a lot of like medical fields right now are using a
Hold
lot of
on.
patient data.
Yeah, yeah,
So I think it could be like those models if they're trained in differential privacy, then like a lot of patients would like to like not have their data disclosed, right?
yeah, yeah. Hold on. One of my like colleagues like presented an approach at Neurips based on like medical data. If I can share that paper, I'll share it. Yeah, I think it was like ज़्यादा हो गया. Like you can like ask the basics as well. And then कुछ hold on. हाँ डाउट्स नहीं है क्या आ गया समझ पूरा
आप पूछ लो फिर क्वेश्चन इनसे डाउट नहीं नो
like,
रे कुछ इनपुट वगैरह कुछ दैट्स व्हाई अगर मतलब डिफरेंशियल प्राइवेसी इसमें इम्प्लीमेंट हो सके तो इट कुड बी रियली ग्रेट
this is like a paper I shared. It's like uh, discussing the disparate impact on model accuracy. I think Kurname you'll able to get like why it's affecting the privacy or sorry the accuracy that much.
ओके
How it is. Also, mm, this is a good link. Yeah, other than medical data.
yeah like I
Uh,
think a lot of things are currently using it like
let's
Google
take an
Play.
example. Like if we are like there was some survey done by Netflix. You must have heard about it. Like what they did is like they took reviews from their customers and like rather than taking their name into consideration, they were assigning them some IDs so that they're like the anonymity can be maintained. But what some adversaries did was like they took that data set and was able to like cross check against IMDb and get the profile of the uh, what can say reviewers.
User, yeah.
Yeah, users. So that's like a gap there. So differential privacy was then like became the hype. Like there should be some.
Yeah, because like even if you networks could be like even if you anonymize the user and use that data, like there are a lot of like open data available on the internet that could be trained on a network, and it could probably cross check that user.
Yeah. So yeah, that's what I'm saying. Like there was simple example that explained how differential privacy was maintained.
So like
So
Google, this AdSense and everything, it uses differential privacy, like recommendation algorithms.
I think like recently Twitter changed their terms of agreement that we'll be like doing some research and analyzing our algorithms and providing like adding differential privacy to them because like many of the tweets like lead to very dire situations. So
Yeah.
they come up with those terms of agreement. I think in Google also, like if you read through their terms of agreement, there are points regarding privacy. So I think their software or products use privacy at some level.
Mm,
Uh, yeah, they must be using because if they have like developed a library for it, I think they must be using.